Hey folks, this lesson is Measure on Position. This is percentiles and Z-scores. Let's go ahead and get started. Should be pretty fast and hopefully easy. So to find the percentile that corresponds to a specific data entry, then our formula is the percentile of whatever our number we're focusing on is the number of data entries that are less than that number divided by the total numbers in that data, and then we just multiply it by 100 because that moves the decimal over 2 places, and that tells us what percent it is. So here's the data below for find the percentile that corresponds to 30. Okay, well, let's look at these numbers. They're not in order, so we have to rearrange these numbers and put them in order. Okay, just slid that up. Okay, so here we go. So there they are in order, and then we locate 30. So there's 30 right there. And then we count how many number of datas that are less than 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 pieces that are less than 30, and there's 25 altogether. So 9 divided by 25 will give us a decimal, so multiply it by 100 to move the decimal over 2 places. So that it says 36, so that means that's 36 percentile. 30 corresponds to the 36th percentile, or 30 is greater than 36% of the data. Okay, I just slid that up right there. Okay, so then we have to do Z-scores. We'll talk about this a lot for the rest of the year in this class, or almost the rest of the year. So Z-scores represents the number of standard deviations that lie from the population mean or the sample mean too, which is sample mean is X bar. The population mean is that mu thing right there. Okay, we're going to focus on the population mean for now. So to find the Z-score value, then we do the whatever value we're talking about minus the data's mean divided by the data's standard deviation, and we know how to calculate mean. We know how to calculate standard deviation. Okay, so each x minus the mean divided by the standard deviation, and that gives us what's called our z-score. It's our number of standard deviations from the mean. So when z is negative, you guys, that just means that the x value is less than the mean. When it's positive, the x value is greater than the mean. And when it's equal to 0, that just means that particular x value is the same as the mean, okay? So z-scores are used to identify an unusual value of data set that is approximately a bell-shaped curve, okay? And I know that you're thinking, what the heck? It'll make more sense as we get going. Okay, now, if you're going to plan on taking the AP Stats test, they talk about the empirical rule or the 68, 95, 99.7 rule. So if we have a normal distribution, which is a bell-shaped curve, you guys, with your mean mu and standard deviation of sigma, remember that funny little hooky r is sigma right there, and this funny mu shaped here. Let's see if I can draw this. So here's my mu shape here, so that's the population mean, something like that, and then this is the standard deviation. Whoops, I kind of goofed. So there's the standard deviation. Anyway, something like that. That's those funny symbols. Okay, so if we have a bell-shaped curve, then approximately 68% of the data falls within one standard deviation of the mean. So it could be one standard deviation. Say this is the mean right here. You have this bell-shaped curve that goes up like this. Sorry, your mean would be right in the middle. So there's the mean right there. Okay, and then so if we go back one standard deviation, don't worry, I got a better picture than this. There's one standard deviation. This is 68% of the data. This is -1 right here. This is +1 right here. So one standard deviation, z is, okay? All right, and then within 2 standard deviations is 95% of the data, and within 3 standard deviations is almost all of the data. Okay, so 99.7% of the data falls within the 3 standard deviations. So here it is right here. Here's our picture, okay? So here's the mean, which is always is 0. And so one standard deviation to the left, one standard deviation to the right, okay? Now if the mean's not 0, we'll learn how to calculate that. We can still get z-scores that tells us how many standard deviations it is. So our formula, you guys, it doesn't mean that the mean is 0, but it converts it to a 0 score, so we can use the standard deviation table. Okay, so anyways, this is 68% of the data, and then within 2 standard deviations, so 2 on this side and then 2 on this side is 95% of the data, and then 3 standard deviations to the left and 3 standard deviations to the right, is 99.7% of the data. All right, you guys, if you are in my class, you're going to get that assignment. Take care.